Okay, so let's take a look at this example. Now, as I've mentioned, whenever you see an example or a question for data involving two groups, the first thing you need to do is to distinguish whether it's a paired data or it's an independent data. So we have talked about that at the beginning of this handout. You know, there are two types of data, paired data or the independent data. So this is one of the example in our discussion board. We have already known that this is a pair data. So the first step, identify the data type. This data is paired data because we have two measurement on each unit. So this is the same subject having two different measurements. So we know this is a pair data, and we have mentioned for pair data, we are focusing on the differences of the data. So we are going to do our inferences. You see, for the confidence interval, for the hypothesis test, all is about this sample differences, D bar. So what we are going to use is this, right? This is the difference, the sample difference of the two groups. So please be careful that this is not the same as the moon days minus the other days. It's not the first column minus the second column. You can see that the standard deviation, especially the standard deviation here, is 1.5 for the moon days, and it's 0.44 for the other days. You are not going to use the first two lines. The mean is the mean of the moon days minus the mean of the other days. The standard deviation is the standard deviation of the moon days minus the other days. That's not correct. You see, this is 1.5 minus 0.44 for the standard deviation. That is 1.06, right? You are not having the same value here. So the difference of the moon minus other, this is the standard deviation of the differences. This is the mean of the differences. It's not the differences of the mean. It's the mean of the differences and the standard deviation of the differences. I hope I made this clear. Let me say it again. You are going to use the last line for pair data because we are going to use the mean of the differences of the two groups and the standard deviation of the differences of the two groups. We are not going to use the differences of the mean and the differences of the standard deviation, although it sounds really similar, and I'm not sure if sometimes, you know, people say it that they probably will have slips of tongues, but you can see the number here. They are not the same value. So we are going to use the last line. Thus, we use data from the difference row. to calculate the to calculate the confidence interval or conduct the hypothesis test. This is in short for hypothesis test. Now let's do the hypothesis test first. So we want to test the hypothesis that dementia patients are more disruptive during full moon at 1% significance level. So the first step, establish H null and HA. The H null is mu D equals to 0. And remember, the null hypothesis is always going to be with the equal sign, and we are focusing on the parameter of the differences of the two groups, right? The mean of the mean of the differences of the two groups versus the alternative hypothesis is going to be you are trying to test goes to the alternative hypothesis. You are trying to see the patients are more disruptive during the full moons at 1% significance level. So this differences here calculated is moon minus the other, so it's mu D greater than 0. We are going to see later on that as long as you are consistent along with your question, it doesn't matter whether your differences is calculated using moon minus other or other minus moon. If your differences is calculated using other minus moon, then you are going to do a alternative hypothesis with a less than 0 sign. But it doesn't matter, again, as long as you are consistent along the same question, you have no problem. Here, the differences are calculated using the moon minus the other, and we are trying to test that it's more disruptive during the full moon days, so we do have mu D greater than 0 here, where we have mentioned this mu D represents the population mean difference, which is moon minus other in average, I would say on average of disruptive behaviors. So this is the first step, establish null hypothesis and alternative hypothesis. Second step, check on the conditions. So the sample is random. It doesn't say whether the sample differences is random or not, but I'm sorry. The sample is random, so the sample differences will be random. It's not saying whether the sample difference follows normal distribution or not. So we have to assume that the difference follows the normal distribution. Okay, so after checking the conditions, we are going to calculate the test statistic. The t-test statistic will be calculated using this formula here, right? We are just going to put the numbers into this formula. So the D bar is 2.43 minus mu now is 0 divided by the SD is 1.46 divided by square root of sample size n equals to 15 is here. For a random sample of 15 patients here, and again, it's a pair data, so the two groups are having the same sample size. This is the common sample size n equals to 15. This is 6.45. Now then, we are going to find out the p-value, right? How will we find the p-value? Suppose this is the null distribution. It's a t distribution with degrees of freedom equals to n minus 1. That is 15 minus 1, 14. Now we are trying to find the p-value. The p-value is calculated under the null distribution in the direction of HA. We are trying to find the area under the curve, that is the proportion of this t distribution that has more extreme values than the observed test statistic. So our observed test statistic 6.45 is here. We are trying to see what is the probability that we are going to observe a t value that is more extreme than this. This is a one-sided test with the greater than sign. Remember, the p-value is found in the direction of HA, so we are trying to find the area under the curve that is greater than the 6.45. That is our p-value. And if you use the table or StatCrunch to calculate it, this is approximately 0. So our p-value is approximately 0, which is obviously less than our significance level alpha. It has said that the significance level is 1%. So p-value less than alpha, we would reject H null. That means the results are statistically significant. So the last step, we are going to state our conclusion in the context of the alternative hypothesis. There is significant evidence that dementia patients are more disruptive during full moons. And again, this is just a sample from maybe one hospital or one nursing home. When you try to, make a conclusion about the entire population, you have to be careful about, how you got the sample, whether it's representative of the entire population or not. So let me be more careful, say in this hospital, because your sample is just collecting from this hospital, and we don't know whether this hospital is representative for all the population. So, okay, this is how we are going to do a hypothesis test for pair data. Again, the first step is to identify which types of data this is. Then you follow the 4 steps for the hypothesis test. It's very similar to the one population hypothesis test. The most difference here is instead of using the information or the summaries from the sample, we are using the summaries of the differences of the 2 groups. Okay, and in the next video, we are going to continue to talk about this example regarding how to calculate the confidence interval. I'm going to end this video here.